Hi, so for the next part of the video, we're going to go a bit deeper into technical side, which is dimensional coordination or DC. So DC is a 3D reference system made up of points, lines, and planes. It is used to design, manufacture, and assemble components with precision. DC or dimensional coordination, defined as a convention, which is an understanding for the coordination of the dimension of building components. So basically, it's a understanding um, on the of the participants of the convention on the coordination of dimensions. So there is a coordination of dimension of the components and incorporating them in their design, manufacture, and assembly by means of three-dimensional spatial reference system of points. So basically, this coordination of dimension is accepted by the manufacturer, and also the assembler in in assembling the components. So the coordination is in three-dimensional spatial reference system of points, in term of points, in lines, and also planes. So there is a coordination between the of the dimension of planes, dimension of points, coordinate, and also dimension of line. uh, which dictate the size of components. So why is this important? So DC is important because uh, it simplifies design and also simplifies the documentation procedure. So the design and the documentation of the design will be a lot simpler as there is a coordination, there is a petition uh, between the components during designing. So the design will be simpler, and also the documentation of the design is also simpler, and this allows the implementation of computer techniques. So we use computer aided design as the components are the dimensions are repetitive. So this can be seen in beam of Revit beam software. So you see a lot of software that just input the components. So the computer the design already know what type of components, the dimension of the components. So it helps the designer in determining the next part of the design as the components are well coordinated in terms of dimension. And next, it can achieve optimum efficiency in the manufacture and use of components and assembly. So basically, the manufacturer will avoid wastage or having too many molds to produce the components as the sizing are coordinated. So maybe it is a incremental of 3M, 6M, and so on. So it allows optimum efficiency in producing it and also optimum efficiency in assembling the components. Furthermore, after that, you will be avoiding cutting or modifying components and uh, assemblies on site. So there's less wet work, there's less cutting. So components are well fit together on site to form a structure. And then it reduce non-standard or dimensionally incompatible component assemblies. So there is will be less non-standard or dimension incompatible. Only a few, maybe a few section that you cannot change as the it requires by the design. So maybe some of components that need to be non-standard, but most of the components will be standardized. So this allows much faster construction. Now, what makes a good module? What are the characteristic of a good module? So you can have, Malaysia, we have a standard of MS1064. So the experts that come up with the MS1064, uh, you know, uh, specify the modules for Malaysia. So you can have another module in other countries, but A good module need to have a good characteristic lah. So we're gonna go through a good characteristic of a module. So first, the module should be small enough to allow design flexibility. So the sizing 1M, 3M, for example, Malaysia is 1M is equal to 100 mm. So you can have one module is equal to 25 mm. If you prefer, but on Malaysian standard is 100 mm. So the sizing 100 mm is very small now, 4 inches. So you can have the incremental. For example, you have a beam of wide 300 mm, the width of 300 mm. So you can have a 3M. So it's easier to specify, and also your design can have like, for example, 350. So it's a 3.5M. So there's a flexibility there for you, for designer to specify their sizing for their components, beam, doors, windows, and so on. And then next one, a module should be ergonomically designed to promote efficiency. So the components are designed ergonomically. The module can be suit to design a component that is ergonomic, for especially when we talk about ergonomic, it relates to human nature. So that module needs to be can be suit for ergonomic design. Next one is industry friendly and features that not only cater for manufacturing but also the transportation and assembly requirements. So you have a requirement on transporting and assembly. So it shouldn't be long enough, too long, that it it will be hard to transport, and then maybe it's too large that you can't, you can handle the object during the assembly. So these are need to be um, considered during coming up with the modular. And then the last and not least is to be internationally accepted, so that you can have a support from the foreign, international supplier, and you can have all sorts of components that fit your module. So then these four needs to be considered in coming up with the module. So MC, modular coordination, is not just a design tool. So it's a concept that applies across the entire building process, from designer in designing the components to manufacture the components, supplier of the components, and then to the assembler. So MC influences how we position and size, specify the dimension of the component. So it even affects how we work on site. And here's something interesting. MC allows for relative independence in decision making. So as long as everyone uses the same dimensional language, 1M equals to 1mm, teams can work autonomously yet still stay coordinated among the parties. So as you can see in the figure here, we can see there's roof, uh, prefabricated wall, prefabricated column, prefabricated flooring. So these are all coordinated between the designer, the design, the size of wall, column, engineers design the column or structural components, uh, and these all come together as the coordination are well versed by all the parties involved in the designing and producing the component and assembling the components of the building. So next we're going to talk about more on modular coordination concept, and also what are the components that we need to really uh, s- go through in coming up with the modular coordination uh, related to civil engineering.